Hi guys, so today we're talking about special functions. If you look in the book, I'll have a little bit more description of each type. But I'm just going to do a general overview of what they kind of look like here. Okay. So the first is a step function. The reason why it's called a step function is because it looks like steps. Um, so it generally looks like this. And the parent function of it looks something like this. Okay. So that's going to be a step function, or in this case, our greatest integer function. Okay. Our constant function is when we have a horizontal line. Okay. For this, it would be a y equals a number is your constant function. Your identity function, okay, is exactly the slanted positive line of y equals x. Okay, it's identity because it equals y equals x. Okay. The absolute value function, an absolute value function looks like a v. Okay. This is the parent function. It has an absolute value. Okay. And then a piecewise function, normally it has different pieces, and that's why it's a piecewise function. You can have a whole different types. You can have ones consisting of several lines. You can have ones that is a line and then like a parabola, and then like, let's say another line, but like, this is just an example of a piecewise function. Note it has several pieces. And when we write it, it has y equals, and then I'll have different equations, right? So I'll have like something like y equals negative x, y equals x squared, y equals negative 3x or something. And then it will have a domain that goes with it, right? So this is if x is less than 4. This is if, let's equals 4. This is if x is between 4 and 6 or something, and then this is if x is greater than 6 or something like that. It'll have different pieces to it. Okay. Your job mostly is just to be able to recognize it right now. And then I don't know why our Algebra 2 textbook never really teaches you how to graph these. Although it's important, the way that they're just having you graph it is just plugging in numbers. Okay, so yeah, that's just the way that we're going to do it, since that's how they do it. They don't care about teaching you how to officially graph it. And so we're just going to do, whenever you don't know how to graph something, you just plug in numbers and then graph the points and kind of connect the dots. Okay, it's not perfect, but it at least gives you a general idea of what something looks like. Okay, so we're going to start with example 1, the step function. Okay, here it says the No Leak Plumbing Repair Company charges $60 per hour or any fraction thereof for labor. We're going to draw a graph that represents this situation. Okay, so here, my x is going to be my hours that we hire them. Okay, and then this is how much the cost is. Okay, so we can do like something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since it's in $60 increments for the cost, I'm going to do 60, 120, 180, 240, 300. This is 360, 420, 480, 540, and 600. Okay, so for the first hour, it charges $6 per hour. So even if I don't get them for an hour, even if my work only takes 30 minutes or whatever, sorry, just let it focus. Even if it takes 30 minutes or whatever, it's still going to charge me for that whole hour. Okay, so that means whether or not up until that first hour, it's going to charge me $60. So At 0, I pay nothing. Okay. But up to 1 hour, it's going to charge me $60. Okay. From anywhere between not 1 hour, but like an hour and a second or something, up until 2 hours, it'll charge me $120. Okay. For 3 hours, anywhere between 2 to 3 hours, it'll charge me $180. Okay. And then you can kind of see the pattern where I'm going with this. Okay. The reason why the open circle is to the left, okay, is because it hasn't hit that next hour mark, right? So obviously if I didn't hire them at 0, they're not going to charge me $60. They didn't do anything, right? But anything past that 1 minute, 1 second mark, it's now $60 up until that first hour. Okay? At 1 hour, they're still charging me $60, but once it hits just an hour and 1 second, 1 hour, 1 minute, then it's going to be $120. Okay, and so there you go. Okay, so why don't you try the CYP one here and then come check your answer. Okay, this is what your graph should look like. X is your boxes of newspaper, Y is your pay. Note that your open circle this time is on the right side. Okay, the reason why is because they pay $5 for every full box. They don't give any money for partial boxes, right? So anything from 1 before you hit 2, you're only going to get $5, okay? Right, so you can't have half a box, they're still not paying it because it starts once you have a full box, okay, at $5. If you have 1.5 boxes, still $5. 1 3/4, still $5. It's only until you hit two boxes that you get your $10, right? And so that's why it goes in that way. Cool? Okay, next, we're going to move on to example 2, which is our absolute value function. We're going to graph it on the same coordinate plane, determine the similarities and differences in 2 graphs. Personally, I think you should have learned how to graph this, but, you know, I guess that wasn't an important value they found in this Algebra 2 book, so that's fine. So since we're going to pretend like we never learned how to graph it, we don't know how to graph it, then what we're going to do is we're going to just make a table. So one is going to be for the x and f of x, and then on my other side will be my x, g of x. Okay. So let's do a couple points. It's not going to take too long, so let's do -5, -4, -3, well, I hope I have enough room, -2, -1, 0, 1, 2, oh yeah, 3. Okay, let's just do that for now. Okay. Same thing for this, -5, -4, -3, -2, -1, 0, 1, 2, 3. Okay, so let's start. Okay. I'm going to do one of them in pink, and I'm going to do the other one in another color. Okay, so here, absolute value of -5 is 5. 5 plus 1 is 6. Okay, absolute value of -4 is 4. 4 plus 1 is 5. Absolute value of -3 is 3. 3 plus 1 is 4. Absolute value of -2 is 2. 2 plus 1 is 3. Excuse me. Absolute value of -1 is 1. 1 plus 1 is 2. Absolute value of 0 is 0. 0 plus 1 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. Absolute value of 2 is 2. 2 plus 1 is 3. Absolute value of 3 is 3. 3 plus 1 is 4. Okay. Then I'm going to connect it. Okay. Again, absolute value should look like a V shape, so you should be seeing a V shape here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. And then I have -4, 5, -3, 4, -2, 3. I have -1, 2. I have 0, 1. And I'm back up with 1, 2, 2, 3, 3, 4. And then we can probably guess the rest of it here. Okay. So again, should be V-shaped. Okay, and then here is my f of x. Okay, so then my g of x, I'm going to do in blue. Okay. Okay, so plugging it in here. So absolute value of negative 5 is 5. 5 minus 2 is 3. Absolute value of negative 4 is 4. 4 minus 2 is 2. Absolute value of negative 3 is 3. 3 minus 2 is 1. Absolute value of negative 2 is 2. 2 minus 2 is 0. Absolute value of negative 1 is 1. 1 minus 2 is negative 1. Absolute value of 0 is 0. 0 minus 2 is negative 2. Absolute value of 1 is 1. 1 minus 2 is negative 1. Absolute value of 2 is 2. 2 minus 2 is 0. Absolute value of 3 is 3. 3 minus 2 is 1. Okay, now I'm going to graph my points. So negative 5, 3 here. 1, 2, 3. Negative 4, 2. Negative 3, 1. Negative 2, 0. Negative 1, negative 1. 0, negative 2. Back up now. 1, negative 1. 2, 0. 3, 1. Should get the point. Okay, so for your absolute value, you don't have to do as many points as me. You might want to do more. Okay, I would do however many until I can see the V shape for an absolute value function, because absolute value is V shaped. Okay, there you go. This is g of x. Okay, so here you can see my graph. Okay, so that's what the book did here. They graphed the points. They connected it. Theirs isn't as, theirs more zoomed in. Okay, so same thing. Okay, and then here is where they talked about some of the similarities, right? So for both of them, the domain is all real numbers. Okay, the range, however, is different. For the f of x one, it starts at 1 and goes to infinity, so that's why y is greater than or equal to 1. Versus for the g of x1, it starts at negative 2 and then goes up to infinity. Okay, they have the same shape. It's that V shape, right? It's the same. How wide it is the same. The difference is they have different y-intercepts. Okay, and then what they also realized is that comparatively, the F and the G1 is 3 units below it, right? It is 1, 2, 3, and then you'll get the point for your G of X. Okay, and you see that here. Okay. Okay, so can you try number 2? You're just going to be graphing it. Okay, this is what your graph should look like. F of x is the pink one, g of x is the blue one. Right, so what I've noticed here with my blue, just because of the points that I picked for my x, I barely got that v in, right? So again, you might have to do some more sometimes in order to see that v shape. Okay, so next part is example 3, piecewise functions. Okay, there's several different ways to graph it, but let's just get started here. Okay, so here I'm going to do a table again. There's ways to graph it. Again, I don't know why the book doesn't care to teach us how to graph it. I feel like it's important to know how. But since they don't, we will just do it the way the book tells us to. And then, yeah. Okay. Yeah. So basically what's important to realize is here we have two pieces. One piece is for where x is less than 2, and then one is for where x is greater than or equal to 2. Okay, so this isn't part of the graph, but just so that way we can see where the divide is, this is where the divide is. This is where our two pieces are going to be separate. Okay, so on one part, we want x minus 4 all the way up until where this yellow line hits, and then for where y is 1, then we want it here. Okay? So one way you can do it is you can plug in points. Okay, so one part, maybe you want the parts that are less than 2, so let's say like 0, 1, and then 2, where it is. This will be the less than 2 part. And then the other part we want actually where 2 is, 3, and 4. Okay, so that's one way you can do it. And then you would just use the part that corresponds to it. Okay. Or the other way is you actually graph the pieces and you can erase it, and et cetera, et cetera. Okay. All right. So one way you can see it is like here, this is a line. So we want the line of x minus 4 up until here. Okay. So here, the y-intercept is at -4. 1, 2, 3, 4. Okay. And then the slope is 1. So up 1, right 1. All the way until we get to 2. But here, it's not included. And so then it will be an open circle. Okay. So here, we want this line, but only up until, well, this graph is bad, up until that part here, okay? And it's open circle because this x minus 4 doesn't apply to 2, right? So the other way you could have done it is you could have plugged in the point. So 0 is less than 2, so I'm using this one. 0 minus 4, that's -4. Okay? So that's why here I have a point at 0, -4, okay? I could plug in 1. 1 minus 4 is -3. And so that's why I have a point here at 1, -3. This part is the less than 2, so that way I know where it borders. So 2 minus 4 is -2. However, it's not included. That's why it's an open circle. Okay? And then here, for 2, 3, 4, the y is always going to be 1. So 2, 1, 3, 1, 4, 1. So 2, 1, 3, 1, 4, 1. Or another way to see it is it's the line y equals 1. So here's the line y equals 1. And it'll be for this side, right? Again, the book doesn't really explain how to do it, and if it actually had a section on piecewise functions, I would probably explain more in depth on how to graph it. But since the book doesn't seem to care, we're just going to piece our several parts together to get it, okay? So here's the next part. You're going to try it on your own. It's up to you. So one way you can do it, right, is I would figure out where the partition is. Okay. You can graph that whole part, right? So one way some students, when I teach them how to graph it, is they'll graph the whole x minus 4, and in pencil, okay, they would draw the whole line. Okay. And then since they only want the part that's less than 2, then what they would do afterwards is they would erase this part. Okay. Then they'll graph the whole thing of the next part. So the next part here will be y equals 1. So then they'll graph the whole line, right? But then they only want the parts where the x value is greater than or equal to 2, this part. So what they'll do is then they'll just erase this part of the line. Okay, so that's another way to do it. Okay, so try number 3 on your own. Okay, and then check your answer. Okay, this is how it should look. So either you could have made your table, or an easy way to graph it. Okay, the partition is here at 0, so I just put a pink thing so I know where the partition is. Okay. One way you could have graphed it is first graph the x plus 2. That's a line. So y-intercept at 2, up 1, right 1, up 1, right 1. You could graph the whole thing. Okay. However, I only want the x values that are less than 0. So that's on this left side. So erase that other part of the line. Okay. Then moved on to the next part. This is x. Okay. So that's y equals 1x plus 0. So here's the y-intercept at 0, and then it's up 1, right 1. And then you could connect all of it if you want. Draw the whole line. Okay, but we only want this side of it, so then I would erase whatever was there. Okay, that's one way to easily graph step functions. Okay, or you could do the table as well. Okay, last part is just identifying functions, determining which one it is. Okay, so it would help if you have the list here, kind of like how I have a picture of what it looks like here. Okay, so here A. It kind of looks like steps, so this is a step function. Okay. B here, it's a horizontal line, so this is a constant function. Okay, and then try 4A and 4B, and then check your answer. Okay, 4A is an absolute value function. It's that V-shaped, symmetrical V shape. And then 4B is your piecewise function. It has your 2 pieces here. Okay, that's it for today. Have a great rest of the day. Bye, guys.